Welcome everyone. Here's another very fun and interesting integral for you. Let's see how we're going to approach this. So I see that I got a sine of 2x here. So immediately I would think of an identity that I can replace this with. And then on the denominator, I see cosine to the fourth power. Well, I might want to rewrite that as well. But let's go with rewriting sine 2x. So recall that sine of 2x is equivalent to 2 sine x times cosine of x. So that's one of the identity we know from trigonometry. So let's plug that in here. So we have the integral of sine 2x. We're writing that as 2 sine x times cosine of x all over. Now, cosine to the fourth power, I'm going to write that this way. I'm going to write that cosine maybe not actually. Let me keep it as it is for now. You'll see me rewriting a little bit later. Now, what I realize here is that I can kind of do a U-substitution. So if I choose U to be just cosine of x, and then on the denominator, it will look like 1 plus U to the fourth. And the numerator, you can also rewrite that. So check this out. So if you let U to stand for just cosine of x, then the derivative of U respect to x will be negative sine x dx. And that's exactly what we got right here. So I got a sine x dx. And of course, cosine, we're going to be replacing that with U. So that's already been taken care of. And the 2, we can always pull it outside the integral. So as the negative sign. So I got negative 2, the integral. So I'm going to rewrite it in terms of the U variable. So you got cosine is replaced with U. So we got U on the numerator. And on the denominator, I got 1 plus U to the fourth du. So I hope you can see the transition now. And then here, we're going to do another substitution. So the reason I'm going to do that, because check this out. Now, this is what I was thinking beginning of the problem. I can write this as U squared, because that's U to the fourth. And somehow it looks like tangent inverse once you integrate, but let's hold on to that thought, but let's keep going. So let's go ahead and introduce another variable. Let's do W. So I'm going to let W equals to U squared. So then the denominator, I'm going to replace it with 1 plus W squared, because that will be the fourth power. And then dW will simply be 2U du. And check this out. The reason I did that, because I got that right here. Better, I also got the 2 right there. So there's no need to divide by 2. So if you want to make the exact substitution, you can simply just keep the negative there and just put the 2 in there. So 2U du is going to be replaced with dW. And everything works really nice over here. So going back to my integral, now changing it to another variable, we got negative, the integral of 2U du is replaced with dW. And the denominator, I got 1 plus W squared, because U squared is W. And now this is what I was talking about. This is tangent inverse or arctangent. So we know from memory that this integral is negative tangent inverse of W. And of course, plus C, don't forget that. So we finished integrating successfully. Now let's retrieve what our variables were. First, I'm going to plug in what W is. That's U squared. So let's replace that. So we got negative tangent inverse of U squared plus C. All right, so the last thing that we want to do is replace what U was. Well, we made the substitution. U is cosine of X. So if I plug that in here, my final answer is negative tangent inverse of U squared. U is cosine. So this is cosine square of X plus C. And there you have it. This is our final answer to this problem.